Hello, this is Captain Chaudhari. In my series of videos on marine astronomical navigation, I was doing time. We were talking about the theory of time, the mean time, the solar time, the sidereal time. It's very important in this particular topic, it's very important to understand the principles with the help of numerical, that we do the numerical simultaneously with the theory, or rather we master the numerical and then automatically we also know about the theory. So we'll do some numerical to understand the basic principles of time. Many of the navigational books, they say time is measured from inferior meridian. This is like telling a grown-up boy that apple is something which looks red and its shape is this way. No, we have to understand that today's navigator is well equipped with calculators and he is aware about the basic addition and subtractions. So it is as simple as this: LHA true sun divided by 15 plus minus 12 is equal to LAT. And similarly, there is the formula for LMT where we use LHA mean sun. So if somebody tells me that okay, I want to see diagrammatically LMT is equal to 1600 hours. So what I do is I draw a polar diagram and I say this is observer's meridian. Then I say 16 minus 12 multiplied by 15. That will give me 60 degrees. So LHA of mean sun is 60 degrees. So I put the mean sun over here. Equation of time is minus 3 degrees. It means that on a westerly journey, westerly means clockwise journey. In a westerly journey, if equation of time is negative, so it means that the mean sun is lagging behind the true sun. Mean sun is behind. So if the mean sun is behind, the true sun is ahead by 3 degrees. So if somebody tells me, please show diagrammatically LMT equal to 1600 hours and equation of time as minus 3 degrees, I would draw this diagram. Now in the same diagram, if somebody says I want to see LHA Aries is equal to 120 degrees. LHA Aries is measured from observer's meridian clockwise till the first point of Aries, and the Aries therefore would be over here. What is the SHA mean sun? SHA mean sun would be measured this way. So diagrammatically it can be shown that Aries, true sun, mean sun and observer, they are seen in the polar diagram like this. And mathematically also I can find out the SHA mean sun, and SHA mean sun is equal to LHA mean sun minus LHA Aries. Now LHA mean sun is 60 degrees, which we found out earlier, and LHA Aries is 120 degrees. So we can put this in calculator. 60 minus 120, that will give me minus 60. Let the calculator do the dirty work. If I get minus, don't worry about it, add 360 to it and I will get 300 degrees. So SHA mean sun will be 300 degrees. So knowing perfectly as to where to place the body and why to place the body in a particular position, it is like understanding the fundamentals via numericals. Suppose we talk about India, and India's time zone is equal to minus 5.5 hours. What is time zone? Time zone plus zone time is equal to GMT. And what is zone time? Zone time is also called local time, and when you are on board ship, zone time is also the ship's time. So whether it is zone time, local time or ship's time, when you add this with the time zone, you get the GMT, right? So zone time and local time and ship's time is the time which you see in a clock. Time which you see in a clock can never be negative, but as per our convention, the time zone is negative in east and positive in west. For example, India's time zone is minus 5.5 hours. It means that when India, the clocks show 21:30. So this 21:30 is the zone time. It is zone time because it is the time that is maintained in that zone in the clocks, right? And the zone time can never be negative. So what time you see in the clocks is the zone time or the ship's time or the local time. Now this, when I add with the time zone, which is minus 5.5, I get 1600 as GMT. So that is the relationship between zone and zone time. Zone can be negative in east, positive in west, right? So this is one thing. And sometimes people confuse the ship's time with SMT. Ship's time is the time that is like zone time. While the ship is in a particular time zone, what time is maintained on that ship? What is the time in the clocks of that ship? That is the ship's time. But once again, in which zone the ship is. So that zone, when added to the ship's time, we get the GMT. So sometimes in the logbook, the boys, they write SMT. This SMT should not be written. Either you write ship's time or you write local time. When you write ship's time or local time, in the logbook somewhere on that page, you should write down what is the present time zone. Say it is minus 4. So everybody knows that whatever is the time recorded, minus 4 will give you GMT. So there should be no confusion like that. Suppose I say observer's longitude is 40 degrees east, right? Observer's longitude is 40 degrees east and time zone that is maintained is minus 3 hours, right? And the ship's time is 1600 hours. So how do you show this on the polar diagram? So let's say this is Greenwich meridian and longitude is 40 degrees east, means you have the observer here and this angle is 40 degrees and the ship is on this meridian. So I will draw the ship. The meridian of the ship is 40 degrees. But when you say ship's time is 1600, ship's time plus time zone, that is 16 minus 3 should be 13 hours as GMT. When I convert the time into hour angle or I convert hour angle into time, there is a discrepancy of 12 hours. We have discussed that before. So when the GMT is 13, it is more than 12. So I minus 12 multiplied by 15 gives me 15 degrees. So GHA of mean sun is 15 degrees. So I will put the mean sun over here. So this is the diagram for the situation that observer's longitude is 40 degrees east, time zone is minus 3 hours, ship's time is 1600 hours. Where is the mean sun? Mean sun is over here. Equation of time, we have done this in our previous videos, that equation of time becomes 0 4 times in a year, right? And I had said that there are two components of equation of time, one because of obliquity of ecliptic and other one because of eccentricity of the Earth's orbit. Now let us find out how to find out equation of time. Equation of time can be found out very accurately for every GMT, hour, minute or second. Like for example at 0000 GMT. Suppose GHA sun is 181 degrees and 15 minutes. So please understand, you can look at these columns as if this column is equinoctial and this column is ecliptic. Equinoctial, the mean sun moves and that is indicated by M over here, and this particular column I suggest you should read as GHA of true sun. As I told you, there are only two suns, one which you see and other one which you imagine. So now we can find out equation of time in two ways. One way is to convert the time into angle. As I said, whenever you convert the solar time into angle, there is a discrepancy of 12 hours. So what I do is 00 plus 12 and then multiplied by 15. So that becomes 180 degrees. Because it is originated from mean sun, I call this as GHA mean sun, 180 degrees. But on the other side, as I told you, this should be read as GHA true sun. GHA true sun is 181 degrees 15 minutes. And equation of time as per our convention is always mean sun minus true sun, because all these things are measured westward. SHA, GHA, LHA, everything is measured westward except right ascension. Okay, GHA mean sun minus GHA true sun is equation of time with the sign. So what you get here is minus 1 degree and 15 minutes. So minus 1 degree and 15 minutes is equation of time. It means that the equation of time is negative. It also means that in a westerly journey, that is a clockwise journey, as you see from the North Pole, top of North Pole, in the clockwise journey, mean sun is lagging behind the true sun. True sun is ahead, that's why the equation of time is negative. Okay, let's take another example. Let's say at 1200 hours, the equation of the GHA of true sun is 358 degrees and 40 minutes. Now what we will do is we will convert the hour angle into time. In the last example, I converted the time into hour angle. We had converted GMT into GHA mean sun. Now what we will do is we will convert this angle into the time. And as you know, the true sun gives you apparent time. So what I will do is 358 degrees 40 minutes divided by 15. So this value I get, the value that I get is more than 12. So I minus 12. That gives me 11.91, and in terms of hours, minutes, seconds, I get 11 hour 54 minutes and 40 seconds. Right? 11 hours 54 minutes 40 seconds. This comes from the true sun, so I will call it GHA of true. I will call it GAT. The time that comes from true sun is GAT. But GMT is 12 hours 00 minutes 00 seconds. So when I subtract GMT minus 8, when I subtract GAT from GMT, GMT minus GAT gives you equation of time with the sign. So it becomes 20 seconds, 5 minutes and 00 hours. So 5 minutes and 20 seconds. Now in this particular example, you see that the mean sun is leading in a westerly journey. Mean sun is leading over true sun. So by the convention, the equation of time becomes plus 5 minutes 20 seconds. Right? Now on the daily page, quickly, if you want to find out whether the equation of time is positive or negative. So what you do is you just see the LMT meridian passage that is given in the almanac. Suppose it is 12:12, right? Remember, at meridian passage, LAT is always 12. So LMT minus LAT is 12 minutes. Whereas on the daily page, if LMT meridian passage is given as 11:51, LAT, I told you, is LAT meridian passage is always 12. So equation of time is minus 9 minutes. So this is how you can find out the equation of time for any GMT hour, minute, second, right? All you have to do is convert the time into angle or angle into time. But remember, when you do the conversion, the solar time to solar angle, there is a discrepancy of 12 hours.